Hi, thanks for joining this session on physical science, lesson 4, chemistry. We're going to actually be talking a little bit about the end of 4.2, valence, and then starting 4.3, formulas, because I think those go together really well. So 4.3 does talk about the fundamental laws that it's really important you know, so make sure you review those, make sure you watch those videos on your student portal. But today we're just going to talk about the end of that section, which is valence. So we mentioned before that valence electrons are the electrons in the outer electron shell. They're the ones that matter because they can react with other atoms. And the number of valence electrons controls how one atom reacts with another. So they're super duper important. So we also have a term in your text called valence. So not valence electrons, just valence, but it's related. Valence is the number of electrons in the atom that the atom needs to either give or take in order to have a complete outer shell. So as an example, fluorine has 7 valence electrons. It needs 8 to have a complete outer shell. So fluorine is lacking 1 electron. It needs 1 more. So we say fluorine has a valence of -1. It needs to take 1 electron in order to complete its outer shell. This is different than sodium. Sodium has 1 valence electron, so that shell just has 1 extra electron. It needs to get rid of it. If it gets rid of it, that whole shell disappears, leaving it with a full outer shell. So sodium has a valence of +1. It has 1 extra electron that it needs to get rid of. So again, this is super duper important. This drives like all of chemistry. This is how we figure out what atoms will react with other ones and how many of them, because it figures out how many electrons it needs to take or give away. So in general, metals, which are on the left side of the periodic table, have a positive valence, and then most nonmetals, which are on the right side, have a negative valence. And I made this little chart. You might want to stop and screenshot this or just write down in notes the basic idea here. Valence electrons are easy to figure out if you look at the periodic table. The periodic table is arranged in such a way that each column has the same number of valence electrons if we ignore those crazy middle ones. So all the way on the left, that column has 1 valence electron, the next column has 2. We skip over those transition metals because they have crazy rules that we don't get into in this class. So we skip over to column 13 that has 3 valence electrons, the next one has 4, then 5, then 6, then 7, then 8. So you know how many valence electrons a element has by looking at what column it's in the periodic table. Again, you might want to write this down or take a screenshot or something so you know it. Now, valences is the number of electrons the element needs to take or get rid of. So this is actually maybe even more important than the last slide. You might want to screenshot this one too. So valence is, again, how many electrons it needs to get rid of or take. So it's also arranged by column. The ones in the leftmost column have 1 extra electron. So they have a valence of +1. The next column is +2. We still skip over those middle ones. They're crazy. We jump to column 13 that has +3. Then that column that starts with carbon, okay, carbon and anything under it, column 14, that has either +4 or -4 because it's right in the middle. So it's just as easy for them to get rid of 4 electrons as it is for them to grab 4 extra electrons. So those could go either way. So then the next column after that is -3, and then -2, and then -1. And there's no valence for the ones all the way on the right. Those have a full outer shell. Those are happy. Those don't react with anything. They're called the noble gases because they don't mingle with the other elements. They don't react. They just have full shells, so they have no valence. So again, super duper important that you know this. This is what you're going to need for the next 2 sections. Again, this is kind of what drives all of chemistry. I would suggest writing this down or taking a screenshot or something. So that was the end of that section 4.2. We're talking about valences, but the reason we need to know them is for the beginning of the next section, which is formulas. So the next section talks about formulas and then equations. This video is just focusing on formulas. We'll get into equations next time. So When atoms bond to form molecules, the valences must balance each other. As an example, calcium has a valence of +2. Chlorine has a valence of -1. So if you try to put them together, you can't just have one calcium and one chlorine because that doesn't balance. You have +2 and -1. Those don't cancel out. So all we need to do is make sure that we balance them out. If calcium and chlorine are bonding, you have to have two chlorine atoms to balance one calcium atom. So you have chlorine, which is -1, plus chlorine, which is -1, plus calcium, which is +2. They cancel out and make 0. They get rid of those extra numbers. We just have calcium chloride. And you'll see that when we write the formula of calcium and chlorine together, it's always going to have two chlorines because we need the two chlorines to balance out one calcium. Okay, so you can write the valences as superscripts to help you balance the formula, and then those can go away when you're done. So we have another example. Magnesium has a valence of +2, and chlorine has a valence of -1. So when you put them together, you're going to have magnesium +2, chlorine -1. That doesn't quite mesh, so we need to have two of those chlorine atoms. So we keep this subscript 2 because this is important. That's telling us we have to have two chlorine atoms. But when we write the final formula, we can get rid of these valences. We've already dealt with those by figuring out that we need to have two chlorine atoms, so we don't need to write them again. So our final formula, we just write, okay, we have one magnesium, we have two chlorines. It, I guess it's a little bit confusing, but they never bothered to write a 1. So magnesium, we have one of those, so you could technically write magnesium 1, chlorine 2, if that makes you happier, but they don't ever write it in chemical formulas. So if you just see a chemical symbol and there's no number after it, you just assume it's 1. Now here's a trick to it. So, I mean, this, on the previous slide, this is what we do and why, and this is just a trick to help you figure it out quickly. So you know the valences, you get those from the periodic table. I mean, you get those by knowing what column it's in the periodic table. And you write the valence from the first atom as the subscript for the second atom, and then the valence for the second atom is the subscript for the first atom, and that helps you balance it easier. So this is what it looks like. If we have, sorry. If we have aluminum and oxygen, the valence of aluminum is -2, the valence of oxygen is +3. So all we do is say, okay, we're going to put this number here as the subscript, right there, put a 3 there, and we're going to put the 2 over there. And that's what we did down here. So we have aluminum, we still have the -2 for now, and we put a 3 there. Because we just kind of, again, this is just a trick. We're just cheating. We're taking this number, and we know that number has to go with the first element. So we just switch them. So aluminum, -2, we're going to put a 3 as the subscript. Oxygen has a valence of +3. We're going to put a 2 as the subscript. So you can see that now they will balance out because we have aluminum, which is -2, and we have 3 of them. Well, -2 times 3 gives us 6. And oxygen is +3, and we have 2 of them. Well, +3 times 2 gives us 6. So we have -6 plus a 6. They're going to cancel out. So let's do a couple practice questions where we're just figuring this out. Your text doesn't spend a lot of time on figuring this out with practice questions, so we're going to go over a couple here that I made up. So what would be the formula for a compound of calcium and chlorine? So first, we need to look at our periodic table and figure out what the valences of those two things are. So calcium is over here. It's in the second column as a valence of +2. And chlorine is over here. It has a valence of -1. So calcium is +2, chlorine is -1. So now if we put them together, we just need those numbers to cancel out. So if calcium is +2, chlorine is -1. Okay, we're just going to use that trick from before. We're going to put that -1 with the calcium and put that 2 with the chlorine. And so we get calcium 1, oops, gosh, that should be a L. Sorry. All right, calcium 1, chlorine 2. Just pretend that says Cl instead of Ca. So calcium 1, chlorine 2. Okay, and the reason again for that is because chlorine only has a charge of -1, a valence of -1. Calcium has a charge of +2, so if we want to cancel them out, we need twice as many chlorines as calciums. Here's another one. What would the formulas be for a compound of sodium and phosphorus? So sodium is over here on the left. It's in this first column. It has +1. Phosphorus is over here. It is in the column that has -3. So we know we have sodium is +1, phosphorus is -3. So if we want to make a formula, we're going to have 3 times as many sodiums as phosphorus. So we just take our little trick and we put the number from phosphorus with sodium, and we put the number from sodium with phosphorus, and that's what we get. Sodium 3 and phosphorus 1. Okay, and again, the reason is because basically phosphorus is 3 times stronger than sodium, so you need 3 sodiums for every phosphorus. And one more, let's take calcium and phosphorus. Calcium is in the +2, phosphorus is in the -3. Calcium +2, phosphorus -3. We take the number from phosphorus, put it with calcium. We take the number from calcium, put it with phosphorus. Bam, calcium is 3, phosphorus 2. So this is just how to balance out our formulas. So that's super duper important to know how to do when you get into the next step of chemical equations. So if you have any questions on it, don't hesitate to call your instructor.